Good morning. Hello, Didina.
Hello, sir.
Okay, അല്ലേ?
Okay.
ഇപ്പോൾ നമ്മൾ കഴിഞ്ഞ ക്ലാസ് ഡിസ്കസ് ചെയ്ത് എന്തായിരുന്നു? Okay. In the previous class, we discussed BPN or back propagation learning. Okay. So at first we discussed connectionist learning. What is connectionist learning means? Already it's based on artificial neural network. In the first part, we discussed various concepts in ANN, which you already studied in S7 and S5. Okay. So next we moved to the back propagation learning. This algorithm or method also we discussed in S5 and S7. Okay. So anyway, this is the architecture of back propagation network, and the training algorithm consists of 3 phases. Okay. The first phase is called the feed forward phase. Okay. What is feed forward phase? What is feed forward phase? That is, we will apply an input and we will calculate the final output. That is feed forward phase. Okay. It is feed forward phase. That is, we will apply an input and we will get the final output. That is feed forward phase. Then what we will do? Okay, then suppose this is the output you obtained. Suppose y1 is the output is obtained from y1 neuron, from this neuron. Okay. So then it is matched with the target output T1. If these are equal, then no problem. But if these terms are not equal, y1 is the calculated output, T1 is the target, then we should do some weight correction. Okay. So we will here we should change the weight here. Okay. We should change the weight here. There are different weights, W1, W1K, etc. etc. So we want to change the weight using a error correction term rho k. Okay. Rho k is the error correction term. Okay. Rho k. Using this error correction term rho k, we will find the change in weight in this layer, delta Wij. Okay. We'll find the change in weight. Similarly, here also do the same procedure. Here also the same procedure they will perform. Okay. So basically, we will find the change in weight using the error term in the output layer. Okay. So rho k is the error term in the output layer. Rho k is the error term in the output layer. Rho k. That is called the back propagation phase. This is back propagation phase. Similarly, by using the error term in this layer, we will calculate the change in weight at this layer. Okay, that is delta VH. VH. Using the error terms in this layer, we will calculate the change in weight. This phase is called basically, and these two steps is called uh, what back propagation error phase. Okay. Then the last step is we will calculate that is the third phase. In the third phase, what we will do, we will calculate the weight, final weight. Okay, final weight is equal to, what is final weight? This term plus old weight, V old. V old. This is the concept. So in the last phase, we will calculate the new weight of VH, which is equal to V old plus delta VH. Similarly, we will calculate uh, W old plus new weight here, which is equal to W old plus W old plus delta WH, delta WH, delta WH, anyway, this term. Okay. So this is the concept of back propagation learning. Okay. So this architecture is very important. And next, you can expect very basic level questions from this. Then, so there are three phases. One is this, two is calculation of back propagation of error, three is updation of weights. Okay, three is updation of weights. There are three phases. Okay. There are three phases involved in it. Then the next is which are the activation functions used in it. Okay. The activation function used in BPN should satisfy these properties: monotonic, increasing function, and differentiable. So we will use which function? Sigmoidal activation function. Okay, we will use sigmoidal activation function. And these are the properties of sigmoidal activation function. Okay, continuity, differentiability. These are all mathematical properties of uh, sigmoidal function. Then you can note the range. Okay, if you are using binary sigmoidal, the output will range from 0 to 1. Okay, 0 to 1. Okay, 0 to 1. Similarly, if you are using bipolar sigmoidal, it will range from -1 to plus. Okay. Sometimes in the exam they may ask about the sigmoidal functions. Okay, so okay. So next is the training algorithm. As I told, there are three phases. One is feed forward phase. It is phase one, and in the phase one, input are applied and final output is calculated. So next, each input receive input signal from xi, I is equal to 1 to n, and sent to the hidden unit. Okay. So input unit to receive the input signal and give it to the input unit. So give it to the hidden unit. Okay. Then what hidden unit will do? Hidden unit is set j. Okay. Hidden unit is set j. J varies from 1 to p. Okay. There are p neurons in the hidden layer. So each unit calculate the net input coming to it using this equation. Okay. So this is the net input to the jth neuron. Okay, jth neuron. This is the net input to the jth neuron. So set in j is equal to v0j plus sigma I equal to 1 to n xi vij. Then we will calculate the output of each unit in the hidden layer using the activation function. Which is the activation function here applying? This is activation function. By applying the activation function over the net input is set in j, this is set in j, we will get the output from the hidden layer set j. Okay. So here sigmoidal activation function is used. Okay, based on the input data, type of the input data, we can apply binary sigmoidal or bipolar sigmoidal. Next, what we want to do, so we calculated the output of the hidden unit. Okay, next what we want to do, we want to calculate the output of the output unit. Okay, this is the final layer. So the output unit varies from consists of m neurons. K is equal to 1 to m. Okay, so calculate net input y in k equal to, and that is net input to the kth neuron. Okay, in the output layer, there are k is equal to 1 to m neurons. So in general, uh, the net input to the kth neuron is equal to w0k plus sigma j equal to 1 to p. You can note here, this varies from 1 to p. Why p? Because why p? Because the hidden layer consists of p neurons. Okay, so j is equal to 1 to p, then set j wjk. Okay, so then we will apply an activation function over it. Okay, so we will apply an activation function over the net input. Okay, over the net input, then we will get the output, final output from the layer. So this is called feed forward phase. Okay, this is called feed forward phase. Then we enter the phase 2. Okay, so what is phase 2? Phase 2 is back propagation of error. I told what we want to do, for each output unit yk, compute the error correction time rho k. Okay, rho k. So we want to calculate the error correction term rho k at the output of each output unit. Then rho k is equal to, rho k is defined in this way. Rho k is equal to dk minus yk into f dash of yk. This is defined in this way. Okay, rho k, the term rho k or error correction term in the output layer is defined in this way. Okay, so which is equal to rho k is equal to tk minus yk. What is tk? Tk is the target, yk is the output coming from the yk kth neuron. Okay, so tk minus yk into f of y in k into 1 minus. If for binary sigmoidal we want to apply this case, for bipolar sigmoidal you want to apply this case. So on the basis of rho k, what we will do, we will calculate the change in weight. Okay, I told earlier, on the basis of the this layer error. Okay, this layer. Okay, based on this layer, this error rho k, I will calculate the change in weight between the hidden layer and output layer. Okay, so how can we calculate it? Delta wjk is equal to alpha into rho k into zj. Rho k into zj. Zj is the, what is zj? Zj is the output coming from the jth neuron in the hidden layer. Hidden layer. Okay, hidden layer output ആണ്. Okay, hidden layer. Okay, zj is the output coming from the jth neuron of the hidden layer. So we will calculate delta wjk. Similarly, we will calculate delta wok. What is delta wok? Basically, it is the bias term. Okay, it is the bias weight. Okay, so if you note it, this term. Okay, and this is a bias neuron. Okay, this weight we will call change in weight we calculate. This is bias neurons case. Okay. We calculate this one. Okay. So these terms are calculated and send rho k to the hidden layer and send the rho k back to the hidden layer. Okay. So then what we will do, for each hidden unit set j, calculate rho in j. Okay, this is another error correction. sorry, we will calculate rho in j. Rho in j is equal to sigma k is equal to 1 to n rho k into wjk. Rho k into wjk. Then this is the error correction term. We will calculate the error correction term at the hidden layer. Rho j. Okay. Rho j is equal to rho in j into f dash of z in j. Then we will calculate the weight change. Delta Vij is equal to alpha into rho j into xi. Delta Voj is equal to alpha into rho j. Similar procedure. Okay, like this. Okay, we'll calculate this term also. Okay, this term also we'll calculate. Okay, and so this is backward phase, back propagation of error phase. And phase 3 is updation of weight and bias. So what is updation of weight and bias? That is, we will, as I told earlier, wjk new is equal to wjk old plus delta wjk. This we calculated previously. Okay, by back propagating the error we calculate this term. So it is added with the old weight, then we will get the final weight. So similarly, what we want to do, this is w term. Okay, similarly we want to update the weight v, okay, between input unit and hidden layer. So we want to repeat these steps, these steps until the stopping condition reaches. What will be the stopping condition? That is, we will get the correct expected output. So this is the algorithm. In the exams they may ask this question. Okay. Next we are moving to, so this is about the connections learning or back connections learning. Okay, so this is another type of, you know, the application. I hope you know the application. Okay, so BPN, basically you heard about the deep learning. Okay, DL. Okay, DL is a subpart of sub branch of machine learning. And in the DL, neural network based algorithms are used for solving various classification and regression tasks. Okay, so uh, this is DL is basically the connectionist learning. Okay, and one of the algorithm in DL is back propagation network learning, BPN. Others are Adalin, perceptron learning, etc., etc. Okay, so we want to study BPN here. Okay, now we are moving to another concept. Okay, so in the first part we discussed version space search. Then we moved to skipping two algorithms. We moved to this. Okay, skipping two algorithms, we moved to the back propagation learning and the neural network. Now we are moving to another section. Uh, so this is social and emergent models of learning. This is another type of learning. Okay, social and emergent models of learning. Previously, we studied about the connectionist learning, which is back propagation network. Now, social and emergent models of learning. Okay, so what is emergent model of learning? Emergent model of learning simulates nature's most elegant and powerful form of adaptation. Okay. For example, it is based on the principle of survival of the fittest theory. You know what is survival of the fittest theory? And genetic algorithms are emergent models of learning. So, what is emergent model of learning means? It uses the concept of survival of fittest theory, uh, and genetic algorithm uses this concept. So we want to study genetic algorithm. Okay, so now we are going to discuss genetic algorithm basics. Okay, so this is also a descriptive topic, so I am moving fastly. Okay, okay, social and emergent model. Then basics of genetic algorithm approach. So in the first part, what is the use of a genetic algorithm approach? It is used to find optimal or near optimal solutions to difficult problems which otherwise have a lifetime to solve. Okay. So to solve such problems, we can use genetic algorithm. So basically, genetic algorithm is used to apply very hard problems in computer science. Okay. So by applying the genetic algorithm concepts on such algorithms, you will get a solution which is optimal or near optimal. Okay, optimal or near optimal in a very fast way. Okay, that is the importance. uh, we will get the answers very fastly. Okay, so for example, the best example is shortest path finding problem. Okay. Mm. Okay, so just I hope you know what is shortest path problem. There is a source and destination. We want there are several routes from source to destination. We want to find the shortest path from one source to other destination. If there are millions of routes, then the problem will become very complicated. Okay, to solve such problems, we can use genetic algorithm approach. Okay, so now what is genetic algorithm approach? So this is the basic concept of genetic algorithm. Basically, we have a set of solutions. Okay, the population. We have a set of solutions. That solutions are called population. Okay, what is a population? Population consists of a set of solutions. Okay, so next we will apply a fitness measure. Okay, we will apply a fitness measure on each solution. Okay, fitness measure means how much the solution is suitable. Okay. Okay, so basically population consists of several solutions. For each solution, we can apply fitness measure. And the fitness measure indicates how much the solution is suitable. How the solution is suitable. Okay, it is a we will get a measure. Okay, then what we will do? We will apply selection operation. What is selection? For example, there are 1 lakh solutions are there. By using the fitness, we will select nearly 50 lakh solutions. Okay, 50 lakh solutions. Then that is selection. Okay, selection means selecting a solution from the population based on the fitness. Okay, there are different algorithms you studied. Which are the different algorithms? Random selection, rank selection. Please refer previous year note S5. Okay, rank selection, random selection, ruled whale selection, stochastic sampling method, etc., etc. There are different selection methods. Okay, so the selection by using any one of the selection method, we will select solutions. Okay, then for what purpose we are selecting the solutions? To perform crossover and mutation. Okay, another operation. Okay, crossover or mutation. That is, uh, we will mix the solutions to get the new solution or better solution. For that, we are using two operation: crossover and mutation. Okay, these operations are applied over the solution. Then we will get new solutions. Okay, new solution. These new solutions will be better than our old solutions. Okay, so next what we want to do, we want to replace the population with the new solutions. Okay, new solutions by old solutions. Okay, then this process is repeated until we get a solution that solve the problem in a very quick way, or uh, until we find a best solution. Okay, so and this is about the genetic algorithm approach. What are the applications solving TSP and Queen's problem? uh, and Queen's is a difficult problem we discussed in artificial intelligence first module. Okay, we want to place queens. Okay, various optimization problem, finding the shortest path. For solving such type of problems, we can use genetic algorithm. Okay, next we want to discuss the general form of genetic algorithm. Okay, this is the general form of genetic algorithm. Basically, initially I told P of T denote population. Okay, population consists of candidate solutions. Okay, it is x1t, x2t, etc., etc., etc. Okay. Now, what is genetic algorithm means? Genetic algorithm means we want to, this is the concept, we want to apply the same concept in a algorithm format. Okay, so we will set a time. Okay, time is equal to 0. Okay, why we are setting time? Because what is the importance of time? Because some usually this genetic algorithm will take will you will always apply it for solving complex problem. Okay, sometimes it may take long time, so by setting a time limit we can stop the algorithm. That is the use of setting a time. So time is equal to 0, we set time is equal to 0, then initial population at the time is pt. Okay, pt. Then while the termination condition is not met. Okay, uh, which are the termination conditions? Just I'm explaining. One is uh, I found a solution, best solution. Okay, I found a best solution. Okay, second one is, for example, time expired. Okay, suppose I set the time for the algorithm is 5 second or 10 second, then if the time is expired, then I can stop the algorithm. Okay, or the algorithm will be stopped. Time expired. In this way, there are different methods for stopping an algorithm. Some Please refer the S5 CSE notes. Okay, S5 soft computing notes, and there are elapsed generation, and there are different methods are there. Okay. Anyway, if any of this is met or termination condition is met, then we want to do these steps. Okay, we want to execute the body. In the first step, we want evaluate the fitness. Okay, evaluate the fitness of each member of the population, then perform selection, select members from population based on the fitness. Okay, then produce the offspring. Okay, we want to create the children of the solution by using with genetic operators. Which are the genetic operators? Which is crossover and mutation. Crossover and mutation. Okay, crossover and mutation. Okay, and there are different methods for crossover and mutation you studied in S5. Okay, please refer that. Then replace, then what we want to do, we created new solutions or offsprings based on the crossover and mutation. Then replace based on fitness candidate of P of T with this offspring. Then set time is equal to T plus 1. This process is repeated until the stopping condition is met. So this is the format of genetic algorithm. Okay. 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 So next, this is the flow chart. Okay, this is the same concept. Okay, so start initial population is there, then selection, crossover, mutation, then termination condition is checked, then this is added back, then this process is repeated until find the best solution. Okay, this is the flow chart, the same concept. Okay, please refer notes. Okay, so next we are moving to the different types of problems. Okay, different problems that can be different problems where we can apply genetic algorithm. Okay, one is TSP. Okay, traveling salesperson problem. Okay, TSP is basically a hard problem. Okay, we can apply TSP genetic algorithm for solving TSP. Okay. Uh, in that case, we don't want to discuss full solutions. Okay, we want to just to discuss the basic concepts. Okay, similarly we can solve another concept called okay, this is the second problem, CNF satisfaction problem. This is also a hard problem. What approach we should take for solving this problem we want to study. Next one is, these are the two cases we want to consider. Okay, so uh, what is TSP? Okay, what is TSP? Now I'm trying to cover the portions very fastly. Okay, so these are descriptive topics, so you can just read and study. Okay, no problem. Okay, so also please refer soft computing notes for more details. Okay, so travel, what is TSP? What is TSP means? I want to, this is, suppose I am here, I want to, I'm a salesperson, I want to visit the cities in a minimum cost way. Okay, that is TSP. Okay, suppose a salesperson have 5 cities to visit and return to home. The problem is to find the shortest path for the salespersons to travel, visiting each city exactly once and returning to the start city. Okay, we want to find the shortest path. Okay, I want to visit each city in a shortest path, then I want to return back to my home. Okay, so this is the TSP problem. And if you consider the state space graph, you can note here, in the artificial intelligence we will apply the state, we can apply state space graph approach. Okay, so if you are applying state space graph problem, the state space of the problem will be like this. Okay, so it will be very huge. Okay, so one approach is you can develop the state space graph like this. Okay, so this is, suppose A, this is one city. B, suppose there are a lot of cities like this. Okay, A, B, C, D, E. Okay, E. Mm. Then the state space of this graph will be very huge. Okay, the state space of graph will be very huge. So searching a state space graph in this, searching a path or shortest path in this state space search is very using an algorithm will be very time consuming. Okay, for example, we can search and find the solution, but it will be very time consuming. Okay, because and there will be a lot of paths. Okay, and the graph size will be huge. So what we will do to solve such in such a situation, we can apply the genetic algorithm. Okay, so here saying the problem, the full exploration of the state space is very difficult. It may want to consider n factorial state. Okay, sometimes we may want to consider n factorial states. So the problem is NP hard. Genetic algorithm approach produces a near optimal solution in a very quick way. Okay, so that is the use of genetic algorithm. So uh, we basically know what is our genetic algorithm approach. Now we want to consider these issues. Okay, so the first issue is we want to represent and encode the solutions to form a population. Okay, in the first step, we want to form a population. Population consists of several solutions. So the first issue we want to consider is which representation will be used for encoding. Okay, this also is studied in the soft computing. Encoding means how we can represent a solution. Okay, that is called encoding. Suppose we have 9 cities. So in this case, suppose we have 9 cities, what we can do, encode each city using a 4-bit. Okay, for example, we can use the binary representation, or numerically I can represent it. So this pattern represents a visit to each city by the salesperson in the given order. So another approach is to give each city a numeric or alphabetic value. Okay, so 1, 2, 3, 4, 5. So what I'm doing here is that this is the visiting city order. In this order, I can visit a city. I can travel. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is one city, 8 is another city, 7 is another city, and so on. Okay. So I can visit in this way. So this will constitute a solution. This is a solution path. I can encode in this way. And another solution path is the permutation of this part. Okay. Permutation encoding can be applied here. That is 3, 4, 6, 7, 8, 9, 12, etc. 9. Okay. So this is one solution. If we apply permutation encoding, the second solution should be different from the first solution. Okay. It should be different from the first solution. So this is not equal. Okay. This should be different. So we can apply permutation encoding here. In the TSP problem, permutation encoding is used. That is, represent each city 1, 2, 3, 4 using 9 digits and encode the solution in this way. This is the first one. Here 1, 2, 3, 4, 5, 6. This is a one travel solution. And another solution is 3, 4, 6, 7, 8. That is, we will use the same city number in different way. In this way, I can find out different solution. Basically, how many solutions I can form, n factorial solutions I can create. Okay, so in the case of a TSP, permutation encoding is the best suitable encoding scheme. Okay, because each solution should be, or each solution path should be different. Okay, so that about that. Next, which fitness function is used? I know here the path length cost. Okay, here the path length cost can be used as fitness function. Okay, least path length cost will be always better. Okay, so I can use this as the fitness function. Next is the third issue is which are the genetic operator that can be applied. Okay. I told mutation and crossover is there. Mutation, in the case of a mutation, random exchange of the two cities in a path. Okay. Mutation operation is there. Similarly, crossover is there anyway. Crossover. Okay, we can discuss the class. This in the next class. Okay. Okay, please give your attendance in the chat box. Okay. Wait. Abhilash. Wait, Abhilash. Next. Ansab. Abhinav absent. Attendance പറഞ്ഞവർ ലെഫ്റ്റ് അയക്കുക. അഭിനവ് ആബ്സെന്റ് ഇടുന്നുണ്ട്. അൻസബ്. ഓക്കെ, നെക്സ്റ്റ് അനുശ്രീ. ഓക്കെ, അർജുൻ. ഓക്കെ, അശ്വിൻ. ഓക്കെ, അതുൽ ദിനേഷ്. അതുൽ സത്യപാൽ. ആബ്സെന്റ്. അതുൽ സത്യപാൽ. ഫജർ. ഓക്കെ, അതുൽ സത്യപാൽ. ഫജർ. ഫബീന. ജാസിം ഹാരിസ്. ഓക്കെ, നെക്സ്റ്റ് മിഥിലാജ്. മിഥിലാജ് ആബ്സെന്റ്. മിഥിലാജ് ആബ്സെന്റ് ആണോ? Mithilaji, Mridula. Next, Muhammad Jasil. Okay. Ramesh, Sharath, Sarga. Ramesh, Sharath, Sarga. Okay. Shabna. Saurabh, Sriraj, Subinraj. Saurabh, Sriraj, Subinraj. Okay. Vishnu P. Then let Amrita, Ashwadi, Harida, Ditina, Amal Sandosh. Okay. Okay. Okay, thank you. Uh, so the absentee is okay, thank you.